Welcome back. We're going to continue our look at solving radical equations here, looking at exercises 9, 10, 11, and 12, and maybe more if we have time. Again, remember that our key strategy for all these is to isolate the radical, whether it's a square root, a cube root, or a fourth root, whatever the root is, we want to isolate that, get it by itself. So, for example, here at number 9, is the square root by itself? No. Okay, what is with the square root that we need to get rid of? This negative 12. How do you get rid of negative 12 times the square root of x minus 6? We'll divide both sides by negative 12. Okay, so that'll cancel. We'll have the square root of x minus 6 equal to 18 divided by negative 12. Okay, both of those numbers can be divided by 6, right? So we get 3 over negative 2, or in other words, negative 3 halves. Okay, we'll then square both sides to get rid of that square root. And we'll have x minus 6 equals 9 over 4. Okay, now 9 over 4, okay, we will add 6 to both sides there. And then 6 and 9/4, well, they're not like terms. So that's really 6 over 1. Sorry, they don't have common denominators. So we'll rewrite the 6 as 6 over 1 like this. We'll multiply the top and bottom by a 4. And that becomes then 24 over 4. And this still stays 9/4, and we'll add those together. So 9/4 and 24/4 makes 33/4. And there's our answer. But we gotta check it, right? Because we don't know if that's gonna work or not. Let's see. So negative 12 times the square root of 33 over 4 minus 6 equals 18. Okay, right away here we can see that you might be able to see that we're not going to get 18 because the square root of something, okay, is going to be positive, and we're multiplying by a negative, and we're then going to say that that's going to be a positive answer. So we're taking something that we know is positive, multiplying with something we know is negative, and we're going to get a positive answer. Is that even possible? No. It is not. Okay, and if you finish this workout here, you'll see that that's not so. Again, 33/4 minus 6 is, if you get common denominators and stuff like that, you're going to get 9/4. Okay, and when you square root that 9/4, you get 3 halves. And you can see again, we have a negative times a positive. That's not going to be able to equal 18. So this is no solution here. Okay, so we'll have to say there's no solution. All right, moving on to number 10. What do we do here to isolate? Why don't you go ahead and pause the video, try number 10. Okay, first thing we should do there is to divide both sides by 3. And we get 4. Then we'll cube both sides to get rid of the cube root. Okay. And 4 cubed is 64. And we'll subtract 2 on both sides. And x is equal to 62. Okay? Sorry, that's my son that you can hear in the background maybe crying. It's that time of day. Okay? Let's see if it works. So 3 times the square cube root of 62 plus 2 equals 12. Okay? 62 plus 2 is 64. Cube root of 64 is 4. And 3 times 4 is 12. So check. 62 does work. Okay. Next one we'll try here is number 11. Okay. This one's already isolated. So again, we'll go ahead and proceed as usual. Why don't you guys go ahead and try it? Go ahead and try 11 and 12 actually. See how far you can get. Okay. So again, hopefully you're able to recognize here that we can at least square both sides to start out. So we have x squared minus 5 equals 4. Okay, we want to get the, now here, because it's quadratic, right, we still want to isolate the x squared here. Okay, we don't need to worry about factoring. You could factor, you could subtract the 4 over and then do like a zero product property and stuff if you wanted to. But since there's just the x squared, we can just isolate that x squared. We'll add 5 to both sides. Get x squared equals 9, square root both sides, you get x equals, now since we square rooted in this situation, we want to say plus or minus 3, and yes, that means we need to check both of them. So imagine plugging in positive 3, squaring it, and subtracting 5 to see if it equals 2, and then plug in a negative 3, squaring it, and subtracting 5 to see if it equals a 2. Okay, in this situation, right, we're going to get 9 minus 5, which is 4. So square root of 4 equals 2, and check that's right. And this is going to be negative 3 squared, which is 9. 9 minus 5 is going to be 4. Square root of 4, again, equals 2. So check that one works too. So both of these answers work. Okay, last one here, number 12. All right, again, hopefully you saw that we needed to square both sides here. And that leaves us with x squared plus 8x equals 9. Okay, in this case, right, we can isolate the x squared, but we also have this x term here. So in other words, using the square root stuff isn't going to really work for us. Instead, what we'll do is we will get it equal to 0 and see if we can factor. So we'll say 0 there, x squared plus 8x minus 9. And let's see, can we factor it? We need two numbers that multiply to make negative 9, but add to make positive 8. Can you think of two numbers that do that? Positive 9 and negative 1. Okay, and so we set each of those factors equal to 0, and we solve. X equals negative 9, x equals 1. Okay, yes, we do have to check both of those back into the original equation. So let's try the negative 9. Okay, and let's see here. Negative 9 squared will be 81. Negative 9 times 8 will be negative 72. 81 minus 72 is 9. And the square root of 9 is 3, so check that works. Okay, alternatively, let's plug in 1. 1 squared plus 8 times 1 equals 3. 1 squared is 1, plus 8 is going to be 9. And check that works too. So both negative 9 and 1 work. All right, thanks for sticking with me, guys, and we'll do some more stuff here in the next video.